Okay, this is a recap video for the Completing the Square lesson, which we did in class together. Apologize, my hand is a bit penned up. I'm filming this at the end of a school day. Right here, I've got the equation of a parabola in standard form, ax squared plus bx plus c. When I have something in standard form, it tells us some information about a parabola. We probably know, well, okay, the c represents the y-intercept, or my initial value. A can tell you whether I open up or down, so I get some information from standard form. But this second equation of a parabola, that's what we recognize, hopefully, as vertex form. It's got a lot more valuable information. So if I have the equation in vertex form, well, first of all, I know my vertex, which is A. That's where the parabola changes direction. And that vertex is always located right on the axis of symmetry. So I also know that my axis of symmetry is that vertical line through x equals h. And that k value, which is the y coordinate of the vertex, is telling us kind of our maximum or our minimum value. So having a parabola in vertex form is really useful. We know all this information right away. It's also when we discuss transformations or we graph with the mapping rule, we like to have that parabola in vertex form. So what we're going to learn today is some algebraic steps to move us from standard form to vertex form. So if I'm given a parabola in standard form, in just a step or two, we're going to figure out how we can express that same quadratic relation in vertex form. And the method that we're going to use is called completing the square. Why do we call it that? Well, you notice in vertex form, I have a squared binomial. So our goal is to make our standard form into a squared binomial. That's why we call it completing the square. So in this recap video, we're only going to look at completing the square when the a value is equal to 1. So this is common in how we learn a lot of concepts in this course. We first look at it when the a value is equal to 1. So let's work through an example together. I've got y equals x squared plus 8x plus 3. So there's a parabola in standard form. Our a value is 1. I eventually want it in vertex form. What I'd really like to have is a perfect square that I could factor. So we talked about this a little bit in class, where this comes from. I'm just going to go through the methods in this video. I'm going to take this middle term, and I'm going to half it and square it. What do I mean by that? I'm going to take my middle term, my b value. I'm going to cut it in half, so 8 divided by 2 is 4. And then I'm going to square it to make 16. In my next step, I'm going to copy down my first two terms, and I'm going to add this number that I found. So I'm going to add a 16. I can't just add numbers to equations. That would change the shape of the parabola. It's not the same as it was before. So why don't we just take away 16? I'm allowed to do that. I'm adding and I'm taking away the same number. It's like I didn't do anything. It's like I added 0. And then I still have my plus 3 on the end. Why did I do that? Why did I add and take away the same number? It doesn't seem to do much. Well, what I can now do is I can factor the first 3 terms and then just collect the last 2, right? Those are like terms. So I'm going to factor the first 3 terms. What are 2 numbers that multiply to 16 and add to 8? Well, 4 and 4. 4 times 4 is 16. 4 plus 4 is 8. So I have x plus 4. It's just a simple trinomial. And then I have x plus 4 again, so I can just say it's x plus 4 squared. So what we did is we picked this number 16 on purpose to create a perfect square trinomial, so that when I factored it, I have a squared binomial. I've completed the square, and now I can collect. Negative 16 plus 3 is negative 13. Now I have this same parabola in vertex form. That's really useful. Right away, I know my vertex is negative 4, negative 13. There's my axis of symmetry. And in this case, there's my minimum value because this parabola opens up. So that's how we complete the square. I'm adding in, forcing this into becoming a perfect square trinomial. I'm always going to factor it into the same bracket multiplied by itself. Let's just do one more example. Again, in today's video, we're only looking at cases where my a value is a 1. Again, I'm going to take that second term, that b value. In this case, I have negative 14, and I'm going to half it and square it. Half of negative 14 is negative 7. Negative 7 squared is 49. So to turn this into a perfect square trinomial, I'm going to write the first two terms down the same, but I want it to be a positive 49. I can't just add a number to an equation, so let's take it away. And then I still have the negative 1. What we're always going to do is I'm going to factor the first 3. And in fact, because we've picked this number 49 on purpose, we've found or chosen that number specifically, I don't actually need to brainstorm two numbers that multiply to 49 and add to negative 14, although you're welcome to. I've picked this number on purpose so that I'm going to have the same binomial squared. It's always going to be half of the middle term. So half of negative 14 is negative 7. Because negative 7 times negative 7 is positive 49, negative 7 plus negative 7 is negative 14. So I've chosen this number on purpose to always create this squared binomial. The number inside the brackets is always half of my b value. And then I just collect. Negative 49, subtract another 1 will be negative 50. Awesome. And now I know my vertex. So we've learned in just one step of algebra, I'm going to flip my h and then have my k value. So we've learned in one quick step of algebra how I move from standard form to vertex form. We call that completing the square. We've got some homework problems to practice this skill, and please let me know if you have any questions. Okay, thanks for watching the video.